Hi group, we're back to looking at risk and return. This is file 6. Here we're looking exclusively at the cap loss pricing model, which is written about extensively in chapter 6. I'm picking out the more important aspects of the model to be able to help you better understand it. So let's start with the learning goals in this chapter. The learning goals are to define again systematic and unsystematic risk and something new, systemic risk. We'll talk about that briefly. You should be able to write the security market line formula. We saw this earlier. Define risk-free rate, define expected return, define beta, calculate R, calculation of the correlation squared, and systematic risk. Now you remember in file 5 we learned how to calculate all that through the regression. So, and the last thing is systemic risk, again, we're going to be talking about. So, again, like we talked about in the first file, we're going to break up risk into two categories: market related, which we're calling systematic risk; business or industry related, we're calling it unsystematic risk. Systematic risk is unavoidable, it's undiversifiable, whereas unsystematic risk is diversifiable away by either holding a wide variety of stocks, so any individual stock has very little importance in your portfolio and therefore has very little influence on return and risk, or you simply shift to a different stock if that's not the stock you want to hold. The stock return that the cap loss pricing model is talking about is assuming all investors are risk avoiders. All public information is available to all investors. Whether they look at it or not is not the question, it's just out there and available. All investors hold diversified portfolios. Business risk is basically diversified away because of the portfolios, so there's no premium received for business risk. So the cap loss pricing model return is going to be the treasury rate plus the premium for market risk scaled for the amount of market risk the company has, plus zero, meaning plus no business risk reward at all. So the security market line formula we saw before in file 1, RC, R is the return, C is the company C, RF is the risk-free rate, which is the treasury rate. We said the treasury rate is known for sure, and you expect to be paid, so there's no default possibility. RM is the average return of an index. It's supposed to represent the average return of all stocks in the stock market. E is saying that this is what we expect the return to be in the future. The ERM minus RF is a measure of the risk premium. It's the risk premium for systematic risk. It's the premium an investor would get with exactly average risk. Here beta is the amount of systematic risk it has. If it's beta of 1, we say that it's exactly as risky as average. If it's a beta of 0, it has no systematic risk. If it's a beta greater than 1, it's more risky than average. Beta less than 1 is less risky than average. And so the risk premium is allocated based on the amount of systematic risk based on the amount of beta. So if we go back to the slide we had before with the formula in it, we can see that RM minus RF times beta, this is the amount of market risk, assuming that we have a beta of 1, but now we multiply by the actual beta. And if it's again greater than 1, you're getting more units of risk premium. If beta is less than 1, you're getting a fraction of the risk premium. So we just got through talking about the relative sizes of beta. Now what we're doing is going through an example. So let's assume the risk rate for this example is 4%. And let's say the stock market is expected to provide a return of 10% during the year. And this is sort of like it has been doing some returns, so we're forecasting this. We have 3 stocks. Beta C has a beta of 1. Company B has a beta of 2. Company G has a beta of 0.75. So how much is the expected return for stock C, B, and G using the capital asset pricing model's single security market line formula? So the return for C is going to be 4% plus 6% times beta. 6% times 1 is 6, plus 4 is 10%. The return for company B is going to be 6% times a beta of 2, so you're getting 12% risk premium, plus the risk rate of 4, 16%. G is less risky than average, you're getting 3/4 of a risk premium, so it'd be 3/4 of 6, which is 4.5, plus the 4% risk-free rate gives us 8.5. So now you can see how we use the beta for this, but it's also important from the regression formula that we spoke about in file 5 that you know that whether that beta is significant or not, whether that's meaningful or not. And also from the correlation, you know whether the 10% or the 16% or 8.5% is the true return, or should it be higher because there is business risk and therefore there's a premium for business risk. So now we're going to look at inflation. What would happen if inflation went up by 2%? Well, the risk-free rate would go up by 2%, and the expected return in the market would go up by 2%. But if we look in red, the risk premium in the center is 12, the risk-free rate is 6, the premium stays the same size, it's still 6%. What's changed is the risk-free rate from 4 to 6%. So when you have 0 beta, the return is 6%, the risk-free rate, where a beta of 1 is exactly 12. If we look comparing the numbers, the two values have gone up by 2%. If we put this in a chart, we'd see a parallel rise in the line, indicating that all returns rose by 2%, and either you're going to receive higher dividends because of this, and that's how you're getting the 2% return, or the prices are going to drop, and the people who buy it at the lower price are getting that 2% return. Here we're dealing with fear. Fear is not going to impact the risk-free rate, it's going to impact the risk premium. So in this particular case, we're assuming a 2% increase for fear. So the expected market return is 12, minus the risk-free rate is 4. So by comparing the two lines for with numbers, we can see that the risk premium was 6 in black, now it's 8 in red. So when we look at the market return with beta equals 0, we see it's 4% in both cases. But with fear, the average return on the market grows from 10% to 12%. So if we draw that line, it's kind of anchored right at the risk-free rate. And what we see happening is it's rising in a counterclockwise fashion, meaning stocks with higher betas are going to have a bigger increase in return to offset the fact that there's more fear about holding them. More intuitively, is the higher the beta, the more the stock price will drop. The person who buys it at the decreased value is getting the higher return when the market rebounds. So this is simply indicating what happens. High beta stocks drop a lot, medium drop less, small beta stocks drop less. When you get all the way down to the risk-free rate, there is no real change. So we have, when the fear goes away, the returns drop, meaning prices have risen. The new buyers are paying a higher price, so their return on investment gets smaller. Going back to the regression for Pfizer, we said that the multiple R with correlation was 71.4%. So 71.4% of the return is coming from stock market returns, or 71% of the return is coming from systematic risk. So the capitalistic pricing model will measure this. It's only going to come up with 71% of the return, not 100% of the return. The R square is 51%, meaning 51% of the variance or 51% of the risk is systematic. So what's the other 49? You don't know. So you could see the capitalistic pricing model is not going to give you an accurate answer. Is the beta accurate at all for the capitalistic pricing model? The answer is yes. We can see that the beta is 1.124. Going over the t-stat, it's highly significant. So we would say we know the beta, it's highly significant, and it clearly explains about 71% of the return. The other is all business risk, and that we can't predict with this model. So I was looking at the regression to get a little feeling what it looks like, and the red dots that form a straight line are the predicted for Pfizer, and the actual are the round dots. We can see that at the left-hand side of the screen, the dot is much higher than the little square. Other times it's below, over around 2%. You can see the return is far below what's expected. If it was a perfect 100% correlation, all of those lines would form, all those dots would form a straight line right along the predicted. The further they are, the lower the correlation between the returns of the index and returns of Pfizer. I chose to look at Walmart. This is another alternative. Walmart has got 39.8% of its return is market related and only 16% of its risk. I did it with a larger number of observations, 53. So we have a highly significant beta of 0.6. but explains about 39% of the return. So this is a very disappointing set of calculations indicating the cap plus pricing model will not work to predict Walmart. I did the plot for Walmart. You can see the scattered dots are far away from the straight line, indicating the fact that there's very, very low correlation, which we knew from the previous slide was only 40%. So this summarizes the cap plus pricing model. It also summarizes the fact that it doesn't usually work, and if you were going on in finance, you'd find that we take the cap plus pricing model and we add more variables to it to explain the portion of the business risk that we can't explain by just simply the index model. That's beyond the scope of this course, but I just want you to know that there is much more sophisticated models than the cap plus pricing model. It was a starting point.